Hi, everyone, and welcome to Statistics this week. We're going to do things a little bit different because I've got a sick kiddo who is in need of my attention, and my husband is team tagging. He's watching him while he's got a stomach bug. It's very pukey. So I am recording this video for tonight's class now. This is the video you need to watch to understand what we're covering for the class. And so without further ado, let's get going and I'll share my screen and we will start our lecture. Okay, now the sad part is I will not get to see. Okay, I think that's better. I think you guys can see that better. Okay, so first lecture of statistics, very exciting. So the first thing we want to talk about is the what. What does it mean? What do we do? Why do we care about that? So first, all of you should have completed the pre-test. Hopefully you guys all got that done last week to discuss kind of what's your current knowledge. Again, no big deal if you're like, it's all Greek to me. The goal is to have you guys way further along by the end of the course. So what we're going to talk about today are the stages of the research process. We're going to define what is an independent and dependent variable. How are they different? We're going to learn how to distinguish the three levels of measurements. And we're going to also distinguish between what is descriptive statistics and what is inferential statistics. And in this course, we're going to cover both. The bulk of our time is going to be in descriptive, but we will dabble into the inferential statistic as well. Okay, who needs to take this class? A whole lot of people. The social sciences rely heavily on statistics when you're doing research. So understanding social phenomenons, it's a huge piece of it. You need to be able to do that in order to use statistics, that is, in order to really have a good understanding of what's going on with the human psyche, with social norms, with political views, really any of those apply. When you look at medical research where you're using a control group, you're introducing a medication, you're also using statistics, but it'll be less of the descriptive kind, more of the inferential kind. We'll dive into all of that this semester and once you get into research methods. So what is the value of learning statistics? And no matter what people tell you, some people are like, statistics is dumb. And there's probably things you've covered in high school that you're like, I am never going to use this again. Statistics is not one of them. Statistics is something you use probably on a daily basis without realizing it. And you will continue to use it because it's infinitely useful. So why do we need to learn about it? Well, we need to be able to interpret polls, surveys, and social research. Now, whether you continue into graduate school, you go further on in your studies or not, having the ability to look at research critically and to not just be wowed and blinded by a graph or a table or values, that's huge. Because so many people nowadays are like, oh, well, there's a table that or a graph and it shows a line going up, that means, yeah, it's increasing, right? They're not paying attention to really what are the axes telling you, how are they measuring it, what's the variable of measurement at the bottom. So being able to interpret is huge. You also need statistic in order to read original research and really understand the analyses that they went through. You also need to have statistics if you're going to conduct your own research. And if you stick around at Aquinas for a couple more semesters and you're in research methods with me or with one of the other professors, you will be running your own research study. And you will need to know statistics in order to actually analyze the data that you get. Should you move on to graduate school, statistics is a huge part of it. Not to scare you, but in my PhD program, there was an entire year requirement of statistics. So it was 3, ours was broken down into trimesters, I guess. But anyway, so a whole year of it. And then because I'm a total geek, I specialized into greater research analysis. So then I took a whole other year on top of it. So like really, we're scratching the surface of the knowledge of statistics here. So it's really cool stuff. And then really knowing how to do data analysis, even common analysis in Excel that we'll learn this semester, that will stay with you in future jobs as well. I have no doubt about that. So, okay, so that's why we do it. Also, it's a requirement of the degree. So you got to do it. So might as well have fun with it. All right, so let's talk about statistics and the research process. So the research process, what is that? So it's a set of activities that social scientists engage in to answer questions, usually research questions, to examine ideas and concepts, and to test theories. So that is a research process. We're going to look at a graph in a minute that describes all of that. Now, what is data? Data is actually numbers that can be analyzed that are using descriptive and inferential statistics. So you get data through the research process, right? Because you ask a research question, you throw out hypotheses that are based on theory, you then go through your methodology and gather data, and the data is then analyzed. So that is then the statistics. It's a set of procedures used by social scientists to organize, summarize, and communicate numerical information or data once again. So those are three big parts as to why we need statistics. So let's talk about the research process real quick. It all starts with this theory, right? So you start at the theory spot is my recommendation. So usually you have some idea, right? You know, maybe theory about learned aggression. You've heard about Bobo the doll in your psych class. You're fascinated by it. You know, I want to say that's Bandura. Now I'm not sure about that. I usually would check it or look at your faces and you go, yeah, that's right, or not. Anyway, so learned aggression, right? So that may be the theory. From that theory, maybe something bubbles up in you and you get a research question. So maybe your question is, this is a good one. Darn it, I wish you were all here because this could be a really good conversation. But maybe your research question is, does engaging in violent or aggressive video games lead to violence or aggression among peers in real life? Okay, so you start from a theory that makes you then think like, I wonder if this learned behavior would also be seen if I'm engaging in a video game. So that's your question. From that research question, you then jog over to the side to formulating a hypothesis. So what ideas or what might you predict based on the theory? So notice this arrow goes back down here. It informs. So you go back to the theory to help you develop your hypothesis. So what hypothesis might you have based on that theory? So perhaps I would create two groups because I'm a good research analyst. And I would have a group that engages in video games, right? So I would make sure that I have age-matched participants in both groups. One group plays this really violent video game. This other group plays like a Tetris non-violent game, right? Still get to play video game, but non-violent. And then I see how they engage with peers through some sort of measure, right? Afterwards, maybe I'm observing them or I'm having them fill out a survey on how amped up they feel, how aggressive they feel. Okay, so perhaps my hypothesis is those who were in a group that actually participated in violent video games are more likely to show aggressive or violent behavior in real life. I'm just making stuff up here. I don't know that that's true. That feels like a hot topic, right? Something that people might have some ideas about. Okay, so that's my hypothesis. I then go into collecting data. So through this hypothesis, I'm thinking through of methodology. How would I gather data? This is where I would actually have my groups play the video games. Again, based on theory, that would tell me how long they would need to observe a certain behavior, and then how I would go about measuring aggression or violence afterwards. So I collect my data. I then move on to analyzing my data. Ding, 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 ding. This is our stats, right? Okay, so from here, I'm going to get a bunch of data and I need to see what it means, right? So I'm going to be doing a comparison. I'm comparing aggression results or aggressive behavior or violent behavior amongst my two groups. And I want to see if there is a significant difference between the two groups. Okay. So this semester, we will talk about what kind of tests we could do to look at exactly that, how to measure a significant difference. Then we move on to evaluating our hypothesis. So we've analyzed our data, right? We've gotten a response. Let's say I found, yes, there is a significant difference. Groups who engaged in violent video games were more likely to show violent or aggressive behavior in real life afterwards. So I just feed that back into my original hypothesis to say I was able to my data supports my hypothesis, right? So that would be this part right here. And then it goes right back up. So notice it doesn't just end here. It feeds back into new research questions. So perhaps based on my data, I discovered that there was a gender difference, right? Again, making stuff up. Let's say that the higher levels of aggression were found in boys rather than girls, or maybe there's an age piece, right? Maybe it's especially salient. And again, I can tie it back to the theory again, to younger children, like kids under the age of 11 are more susceptible to learning violent or aggressive behavior via video games to then translate that into real life. Okay, so the whole point of me giving you this example is to show that the research process is both cyclical and it's self-informing, right? It constantly refers back to the theory to inform the next step. Okay. So when we start and we ask a research question, we want to look at specifically empirical research. So it is research that's based on information that can be verified by using direct experience. So you're not just relying on common sense or reasoning or maybe some speculation. I suspect it's this because it was like this before. It's really actually you're doing the measurement. You are actively researching it. So for instance, an empirical study could be, are women paid less than men for the same types of work, right? You could go out and measure that. You could go and look at average salaries for very similar jobs and see if there's a significant difference between men and women. Now, a study that would not be empirically supported is something that's a bit more conceptual, right? Is racial equality good for society? It's a little hard to measure, right? Like we've got a lot of abstract concepts going on here. So based on either your values, how you're going to be, how you measure good, right? That's a very vague term. It cannot be independently verified. You would need to quantify the question. So we would need to first operationalize what does good look like? Does that mean economic growth? Does that mean decrease on crime? Does that mean greater levels of happiness and satisfaction, right? So psychological health. And then from there on, if we come up with a good definition, now it can be measured adequately and we can turn it into an empirical study. Other research questions, does change blindness occur for scent? Is there a critical period for learning statistics? The answer is no. I often get students who are like, I'm going to struggle. I haven't done math in 15 years. And that's okay, because this class, again, we're going to do some math, but a lot of it is going to be on Excel. So fear not, it'll be a-okay. All right, I've got to take a sip because I'm talking a lot. Okay. What is a theory? A theory is a set of assumptions and propositions that is used by social scientists to explain, predict, and understand different types of phenomenon that humans can produce. So what does that actually mean? So it's really, we're trying to establish a link between what we observe and then our understanding of why people behave the way that they do, right? It's actually bridging that gap. So for instance, are women paid less than men for the same type of work? That ties into a gender segregation theory. That's the theory that says that even though they're maybe performing the same type of work, there's a different outcome in terms of pay, that there is a disparity between men and women in their income for the same type of work, right? Okay, so the example I gave earlier was kind of a learned behavior theory, right? So that you're learning behavior through visual cues to then take on those behaviors. That would then inform aggression and violence in video games. Okay. What is a hypothesis? That's important too. So a hypothesis, and this is key, I want you guys to remember that, it is a statement. It's not a question, it's a statement. And you are opining, you are stating, you are commenting, or predicting the relationship between two or more observable attributes, okay? And those specifically need to be able to be empirically verified. That means whatever data points you have, whatever hypothesis you put out there has been operationalized enough that you can gather data to either support your hypothesis or refute your hypothesis, meaning, no, our study actually didn't support it. Okay, so research question might be, are women paid less than men for the same type of work? That feeds into the gender segregation tier, like I mentioned before. Your hypothesis, though, your statement that is predicting a relationship between two or more variables would be something like this. Occupations that are majority female pay lower wages than occupations that are majority male. Okay, so right in that hypothesis, I've provided enough information that we can operationalize it. So I could take, for instance, preschool and kindergarten teachers that are 98% female and compare it to the income of CEOs who are 95% male. Now, if there's a significant difference in those income, then that would support my hypothesis that occupations where a majority females pay lower wages than males. Hopefully that makes sense. So again, hypothesis is a statement. It is a prediction. Okay, now what's a variable, right? Because the hypothesis is you're predicting between two or more variables. So what is a variable? It's a property of people or objects that takes on two or more values. So why is it two or more? Because if it's, are you a human, right? Everyone is, that's not going to be discerning. When I need a multiple level variable is so there can be categories for the sake of comparison. You need to include categories that are exhaustive and mutually exclusive. So these variables, you can't have some that qualify for both, right? It's got to really just be one or the other. So age is a good one. You are the age that you are. It's not pretend, right? This is what it is. This is how old you are in this moment in time, okay? Political affiliation, again, in this moment in time, you must select one. Which one fits you best? So that would be a variable. Okay, so here's examples of different categories. There's social class, gender that needs to be updated. That is a very old table. Education is another one. Again, some of that I feel like could be defined a little bit better because we tend to be skewing towards more heavily educated, but that's an idea. Okay, obviously we're not doing group work right now as I'm just straight talking at you. So instead, I've opened up a discussion forum for our class. Your job tonight, I'm going to be kind. So oh, sorry about that. You might hear my dogs.
Someone is at the Stonehaven front door.
And also you hear our Ring doorbell. Sorry about that. Your job for today, we're just going to make it, we'll make it this week. Let's be super generous. So from tonight until next week, late Tuesday, your task is to go into that discussion forum and answer these prompts. So usually what we would do would be super fun in a classroom. We'd group 2 to 3 people at a time. We haven't done that in a while. So what I was doing was on Zoom, having people write down their ideas. So this will be all the same. What I want you to think of is 1 to 2 research questions. So I gave you mine, right? So does gender segregation occur in the workplace? Come up with a research question that is of interest to you, then generate a hypothesis based on it, and then figure out what are the variables that you would use to measure. So for the discussion forum, I want you guys to write, each of you needs to have your own response to this. And then I want you to comment or respond to at least 2 colleagues in your class, again, by next week. So this will go towards your participation points for this semester. All right, and you'll see the discussion forum is right on there. All right, let's talk about unit of analysis. So we're going to go from small to bigger. We're funneling out. So first we start with individuals. Those can be individual factors. So what is your age? What is a score on a specific test or survey or questionnaire I'm giving you? What's your occupation? What's your highest level of education? Again, those are all variables that are specific to you as an individual. Then we could take it a level higher, families. So I can ask about how many people are in your family, how many adults. I can ask about your parents, maybe your grandparents. So we're funneling out. Then we can talk about organization. So university, how diverse is it? Are there mostly continuing education? Is it undergrad, grad? What clubs are present? So again, that's at the organization level. Then we go up to city. right? So again, see, we're funneling out. You can't quite see it. Funneling out. So what's the crime rate in your city? How dense is the population? Would you be considered more in a city versus a rural setting? How diverse, and you can break that down into racial diversity, religious diversity. What's the level of mobility? Again, are people living in a certain area but driving further out for work, vice versa? And then lastly, going further out would be social artifacts. So those are things that tend to be culturally bound for an entire culture. So knowing cartoon characters on a cereal box, knowing a specific infomercial or commercial that you've seen on TV, what people wear as a function of their gender. Okay. The whole point is there are multiple units of analysis. Now, in the social sciences, we focus mostly on individuals. Occasionally, we go up a little bit to organization and maybe cities, but on the whole, it tends to be individuals. So this is just a representation of what I was just talking about. Your text has a lot more of those examples as well. Okay, cause and effect. You are going to hear a lot about that in this class. First off, we're going to talk about this thing called correlation this semester. Correlation means how two variables, what kind of relationship they have with one another. You can have a positive correlation, meaning as one variable increases, the other increases as well, right? Both go up at the same time. So if you're imagining, let me draw this here so you guys can see it. Don't mind my other notes about millennials from my last class. But this kind of graph, right, as one variable goes up, the other goes up as well. That is called a positive correlation, okay? The more I eat, the more I weigh, right? Positively related. The more I study, the higher my grade, right? Okay, so that is called a positive correlation. Now you may also have something like this. That is a negative correlation. So the more I do something, the less this other variable comes up. Okay, so here's an example. This is frequency of gym or a length of workout times, okay? Number of minutes I work out per week, and this is weight, right? So the more I work out, the less I weigh. That would be another example. I bring this up because correlation speaks to the relationship between two. It is not causal. One does not cause the other, okay? It has a relationship, it has an impact, but it is not causal. This is one of my pet peeves. We all have them. This is one of mine. So if you ever write this cause that, be prepared for my wrath because that's not how it goes. But okay, so talk about cause and effect specifically for this. What do we mean? So there can be temporal precedence. So something happened before something else. There needs to be an empirical relationship between cause and effect. We're going to dive into all of this again much later this semester. But covariance, so we talked about correlation, covariance is similar. That means as one variable is varying, the other variable varies alongside it. And then there needs to be strong internal validity. Talk about that again. Okay, I feel like I don't want to confuse you guys, so we'll talk about that later this semester. Okay, what are variables? This is important. Quiz time. Hopefully you guys are hearing me, watching this video. This will be covered on the quiz. So a dependent variable is the variable that you are trying to explain away. It's the variable that you are ultimately trying to figure out how it gets impacted by the independent variable. Okay, so with the independent variable is the variable that's expected to account for the dependent variable. Now, depending on what your variable is, sometimes it can be switched around. So an independent variable in one situation or in one study can be the dependent variable in another study. So if you were taking the perceived stress scale, it's a question on how stressed you feel, the dependent variable could be looking at stress level between males, females, gender, majors, jobs. And then the independent variable would be looking at a performance on a specific test. So um, it can be switched around, right? So all to say, this semester, you may see that may differ. So income is a good one. Income can be an independent variable. So if I'm trying to measure, let's be political, right? Because we just had elections. If I'm trying to measure the affiliation with the political party or how likely it was for you to follow a certain candidate in the election, I could look at gender, race and ethnicity, but I could also look at income, right? That income somehow would be predictive as to who you would want to be the next president. So income in this case would be an independent variable predicting likelihood of a political candidate vote. Flip it on its head. I could talk about years of education and its impact on income. So now I'm looking at income as the dependent variable. I'm trying to see and predict if the number of years you are in school correlates to a higher level of income, meaning the more years in school, the greater the income. Newsflash, not always the case. PhDs don't necessarily make more money than people without college degrees. They're in a trade and they make good money, right? Okay. So those can swap depending on your research question. However, some variables are usually, very rarely, usually not ever considered dependent variable. And race, age, and gender are part of that. Those tend to always be independent variables. So the dependent variable is always the property one is trying to explain. I kind of said that already. So you're asking the question, why is it happening? Why are women getting paid less than men? It's the object of your research. It's what you're trying to figure out. The independent variable usually occurs well before. It's often seen as influencing either directly or indirectly the dependent variable. Okay, so let's say you were doing this example. Your hypothesis that people who attend church regularly are more likely to oppose abortion than people who do not attend church regularly. So if we think about independent variable and dependent variable, what would those be? So I want you to think for a minute, maybe pause me because I'm not going to wait that long. But the dependent variable, what you're trying to figure out is people's views on abortion, right? Specifically, do they oppose abortion? And then your independent variable is how often are they attending church? The idea being, I think the hypothesis here, as stated, is the more often somebody attends church, the more likely they are to oppose abortion, okay? Now, you would need to identify certain control variables, certain things that you would need to keep in mind. So maybe denomination, there may be some denomination that even if you go to church once a week or 5 times per week, it doesn't matter. The views on abortion are always going to be held strong. And now we need to be careful because is there a causal claim? Can you say that attending church more often causes you to oppose abortion? I would say no. Attendance does not cause. There is a correlation. There is a relationship between the two, but not a causal one. Okay. I just talked about that. All these things. So independent variable, how often are you going to church? You would need to think about the levels of that, right? Like, would you want somebody to write it in or would you want to give them an option? Never, once a month, once a week, more than once a week, like what would that look like? And then your attitude toward abortion will be your dependent variable. Some control variables, okay, I just talked about that, religious affiliation being one of them. Possibly age, that may be something you want to control for. So picking a participant group that is homogenous or similar in age, or dividing up your group, your participant pool, so that you're looking at I don't know, you'd have to have some sort of reasoning on there. Maybe 30 and under is in one group, 31 to 50. Oh, that's depressing. I just put myself in an older group. But anyway, you would have to make some discernment here on how you would break that up as well. Okay. So again, I just talked about this causal argument. No, they're covariant. It's a correlation. Okay. Learning check. We got all this done. All right. So when we go about collecting data, you have to decide first, what is the way that you're going to measure the variable you're interested in? And then you need to figure out how you'll find your participants. So how are you going to actually collect data? Is it going to be in a lab? Is it going to be online? Is it going to be a paper pencil survey they need to complete? Are you looking at a correlational study that's going to be looking at how two variables relate to one another? Or are you doing an experiment? So this would be, let's evaluate your symptoms for depression. Let's now give you a pill. And now let's evaluate your symptoms of depression. Now we've just introduced temporal precedence, right? How did you feel before? We gave you a pill. How did you feel after? If we controlled for everything else, right? There's been no emotional crisis or trauma that's occurred in that period of time, then we could be good to go. That in fact, whatever change we saw was due to that pill. So when you are designing your study, alongside that design, you need to be thinking, how will I analyze my data? Because obviously that's going to play a role. Okay, levels of measurements. So not every variable can be analyzed by a given statistical test. Some of them, and we'll learn about this semester, you need a specific type of level of measurement. So nominal, that's one of the levels. Nominal is a label or a qualitative measure. So being a freshman, right? Or being a Democrat or a Republican or being Protestant or being Buddhist, right? Those are labels we're giving. We are not measuring something. It's just a label. You're not, 50% a freshman, right? There's no measurement of it. I guess now I'm thinking that through. I guess if you were 6 months into your freshman year, maybe you'd be almost a sophomore. Anyway, we're not doing that. Usually it's a label. So that's nominal. Next is ordinal. So that's a rank and it tends to be quantitative. So we'll go over that in just a second. But again, there's not a meaningful difference between one and the other. So coming in first place versus second place for a race, right? There's an order, there's a rank, but is it meaningful between 1 and 2? The person who wins the huge prize, I'm sure they would say yes. But as compared to an interval ratio, that is a measurement with a natural zero. So you can have the absence of the variable, right? When you're doing ranking, like you can't have a person that's got a rank of 0 in a race. I guess if you chose not to participate, but that doesn't really make as much sense, right? But you can see what is the presence of alcohol, right? By blowing in the thing, the tube or the straw, and then you can have an absolute 0, right? Or you can take a depression scale and score a 0, showing you have no signs of depression. So there can be absolute zeros that way. That is an interval ratio variable. So let's talk about each of them. So nominal are labels, names, or sometimes even numbers that are assigned to a set of categories for the purpose of naming and labeling. So they cannot be rank ordered. So political party is one, religion's another, race and ethnicity is another. They are also mutually exclusive. So if you are saying you are a Democrat, you are inherently saying you are also not a Republican, right? They are mutually exclusive labeling categories. Okay. So those are some examples of that. Marital status would be another good one too. Okay. Ordinal, it's a little bit of a higher, so it's a nominal level, but they can be ranked from high to low. So when you do a Likert scale, like how much do you agree, strongly agree, disagree, strongly disagree, you have a rank there. So you can give it a point, so to speak. So there is ranking, but there's no absolute zero, which is really what differs with interval ratio. So interval ratios are values that can be rank ordered, and it's all expressed in the same unit, and they are equally spaced. So age is a great one for that. It's measured in Earth years or months if you've got a baby. And also, don't be annoying and have like your 5-year-old and you go, he is 64 months. No one wants to know, do the math of that, right? He's 5 years old. So, and the difference between each values does not change. So the difference in age between 25 and 20 is the same as 15 and 10. That difference of 5 years has not changed. So it's equal throughout. Income is another good one. Test scores can be very good as well. It's usually for variables that can have a natural 0 point or the complete absence of a variable. Okay, there's several here. So percentages count towards interval ratio. They can be ranked from lowest to highest. You can then break it down into 2 groups. So you show majority and minority. So there's lots of things you could do to help out. Okay, so possible comparisons here. I'm going to look at the screen, although you probably can't see it. All right, so you can have here in the nominal measurement, graduated from public high school, graduated from private high school, graduated from military academy. Those are all nominal measurements. They've all been labeled. An ordinal measurement, if you're looking at education, would be high school diploma, some sort of college diploma, and PhD. But notice the difference between each of these, that's meaningless. It's not like, oh, well, this one's 5 more than this one, right? There's no numbers. It's a meaningless. So that's why that's ordinal. You're ranking them, but there's not a meaningful difference. Whereas this, you could say this individual has 8 years of education. This one has 12 years, and this one has 16 years, right? So that's a middle school degree, high school degree, bachelor's degree. And there is a meaningful distance of 4 years between each category. So that is an interval ratio measurement. Hint, hint, you want to know about these for the quiz and exam as well. Okay. So this is almost like the square can be a rectangle discussion, but variables that can be measured at the interval ratio level can also be measured at the ordinal or nominal level. So you can always take it a step back. But variables that are nominal and ordinal cannot be measured at a higher level, okay? So I just said that the last sentence is duplication, but again, if you have age, you can break it down into an ordinal with categories, 18 to 25, 26 to 32, right? You can have that group. Or you could say middle-aged, elderly, young, right? Like you can just give it a nominal label. Usually, if you have an interval ratio variable, you want to keep it at that. It just gives you far more flexibility in terms of statistical analyses. Occasionally, though, it's helpful to break it down into smaller groups, like chunk it down into categories. Okay, so there are exceptions to that, and that is with dichotomous variables. Those are variables where you only have 2 options in terms of the value. So again, with gender could kind of qualify in that. We need to refresh some of that. But employed versus not employed, parent versus not parent, depressed versus not depressed. So it's one or the other. So those are the only 2 choices you have. Okay. Now, occasionally you will see this in research articles where they will tell you, you have a group of people, here's their response. There is the white group and the non-white group. Now, I wish I could hear your thoughts on this because there's many things that are problematic. First off, there's the problem that somehow we believe each of these racial and ethnic groups are equal, right? That we can lump them all together because they're just the non-white group. Now, I'm not trying to be offensive in saying this. This actually happens in research quite frequently. In research where we do not have equal groups for each of those racial and ethnicity group, oftentimes they will be combined. And then we look at differences between minority versus majority. And this is usually the theme of those research papers will be in how prejudice has taken place. So favoritize or a preferential treatment, was it given? And then you see a specific experience, and then you see the results for whites and non-whites. So that is a place where it would be an appropriate way to have it divided in just two categories, because you're speaking to a social phenomenon regarding ways the minorities are treated. Any other way you're thinking about it is kind of faulty. If you have the data and you know each of those categories, that's far more rich than clumping them all in a group, because then it erases any nuance for each of those racial and ethnic group, which inherently it is faulty research. But this is the way it would look in terms of a dichotomized variable. Okay, so little cheat sheet here. So these are the different levels of measurement. This is whether they are different or equivalent, right? All of them will decipher if they're different or if they're the same. Higher or lower, that implies some sort of rank, right? Nominal does not. I know some of you guys might think like political affiliation. I kind of think one's better than the other, but that is not an approved upon. There's no rank, right? So as long as we're together on that. And then how much higher, meaning there's a meaningful difference between each category. Only interval ratio data points have that. Okay, another way that we can look at variables, there can be discrete variables. Those are variables that have a minimum size unit of measurement which cannot be subdivided. For instance, number of children per family. I happen to have 4 children, including one who's not feeling well, and I had a different one who wasn't feeling well yesterday. I hope we were out of the woods. It's not COVID, by the way, in case you guys are wondering. I think we've got a stomach bug going through the house, so I'm really hoping it doesn't hit me. So far, it seems to just be the little ones. But going back, number of children per family, that is a discrete number. I don't have like 3.4 children. I have 4, all of them. Sometimes I feel I have 5, but let's not digress into that conversation. I do have 2 dogs, as you guys know, and they're being so sweet. They're just sleeping right here. Here, okay, you get to see my pooch. This is our puppy golden retriever. How cute is he? Yeah, so cute. Okay. Just for those of you who are actually watching this lecture, I'm sure many of you will be like, what? She showed her dog? When? Okay, so discrete variables. So again, whole numbers. Number of cars that you own, number of pets that you have. I have 2 dogs and a cat. Number of fingers. You can see these are discrete numbers. You have a whole number. Now, a continuous variable is one that can theoretically take on any numerical value you can think of. So your length, right? If you're measuring yourself, you're not 5 foot. I mean, maybe you are. Maybe you are exactly 6 feet, but you could also be 6 foot, 0.25 inches, right? Right. So you can take on any level of measurement. Same with age, right? Technically, you can count it in months, you can count it in years, all of that. Percentages are that same way as well. It is a continuous variable. Okay. Now, measurement. We've talked about how we can label and define different variables. We need to have a small talk, and we're going to talk about this again later on the semester, on measurement error. No matter how good of a statistician you are, you will likely make errors. You're not going to be 100% perfect. That's just now how it goes. So within all of statistics, we account for a certain amount of error. We need to be mindful of it. So let's talk about reliability first. So reliability is a measurement that gives consistent results each time it is used. If you have a scale at home and you weigh yourself and it reliably gives you an accurate number, it would be a reliable scale. Now, I should tell you, if you stepped on that scale every single day and it said 3 pounds and you're like, that's definitely not right, but it gives you the same number every day, that is a reliable scale. Let's jump down to the bottom one. Is that a valid scale though? That is the extent to which what is measured, the way it's measured, actually measures what you intend on measuring, right? So If I'm intending on measuring my daily weight of me as a human lady, right? And it says 3 pounds every single day, it is reliable, but it is not valid, right? It is not a valid measurement of my weight. It's probably a broken scale, right? Give you another example. If you are taking a statistics class and your professor gives you, instead of giving you an exam on statistics in English, she decides to give it to you in French, you may very well provide a reliable response over and over again, meaning you're going to be like, what are you giving me, you crazy, insane lady? I don't understand any of it. But it is going to be reliable because you get the same result over and over again. Is it valid? The answer would be no. It's not a valid way of measuring your knowledge of statistics if I'm giving you the test in a language you do not speak. That is not a valid measurement. Okay, so some of the examples I provided here, the Big Five personality test shows high levels of reliability. Same with IQ. Again, crystallized intelligence over time tends to not change. So there's some reliability with that. Now, validity would be, does the test I'm giving actually measure what I think it's giving? The Beck Depression Inventory, does it actually measure depression? Turns out, yes, it's been very well validated in the research. So that's how we break that down between, again, reliability and validity. And we will talk about both of those more this semester as well. How do we analyze this data? Well, there's two ways we can go about it. You can create a study where you analyze an entire population. That is the total set of individuals, objects, or groups that the researcher is interested in. So if I was interested in undergraduate students at Aquinas to investigate the entire population of Aquinas students, every single student would need to be tested. Small job, big job. It's a very big job, right? That is what the census is. So if you think about what occurred, I think it was just last year, right? Maybe the year before. I think it was 2020, where we did the census. They're trying to get data from the entire US population on a variety of things, right? Income within the household composition, levels of education, ethnic and racial background, what sort of religious affiliation you might have. So that is an entire population. The number of studies in the social sciences that focus on an entire population are very small. It is not time effective. It is very costly. It's quite complicated to do. What's far more frequent is having a sample. It is a relatively small subset that is selected from the population. So when you select that subset, that is called sampling. So you can sample students from Aquinas, for instance, to determine how, I don't know, how kind they are or how involved they are with online learning during COVID, right? So we will talk this semester as to how the impact of sampling and whether you do random sampling versus intentional sampling or sampling of convenience. And obviously, once you get into research methods, we'll talk about that quite a bit more. But the idea is we want our sample to be as closely representative to the entire population. So now, if I sample this class, for instance, as to how diverse all of Aquinas was, there might be something inherently wrong with that measurement because the people who are interested in taking a stats class at 6 p.m. at night may not be representative of all students at Aquinas, right? So we need to be thoughtful on how we use our sampling so that it best represents the entire population. We talked about this a little bit at the start of class, but we have descriptive statistics. Those are procedures that help us organize and describe data that's collected from a sample or a population. So I can have measures of central tendencies, seeing what is the average, what is the mean, like where does it cluster towards the middle. I can have measures of variability, that would be standard deviation. We'll talk about that this semester. It could be as simple as a frequency, right? So knowing how many freshmen versus sophomore, juniors, and seniors in the athletics department was. I can create frequencies. That is describing the sample. Now, inferential statistics is using logic and procedures that are concerned with making predictions or inferences about a population, but utilizing a sample. So we'll talk about this later on. Logistics regression or linear regression allows us to do that. So it's understanding what's happening right now and what is most predictive, which variable most predicts a dependent variable, and how can we extrapolate that later on. So again, the statistics that we use, it's the link between the theory that we have and the data, going back to that research process we talked about. Okay, so once we're done analyzing our data, then we go back to evaluating our hypothesis. That's what I was just talking about. So did we find support for or against our hypothesis? Now, we are never going to use words like we prove our hypothesis is right, or we proved our hypothesis, or we disproved our hypothesis. Those are not words we use. So we'll talk about in statistics, we talk about, we could talk about refuting, failed to support, or support our hypothesis. That's the kind of language we'll use, and we'll talk about that later on this semester. It's important to know that if your data, if the statistics you got from it somehow did not go the way you predicted, right? It didn't actually follow through at all what your hypothesis thought. That is not throw away the research, walk away, never do research again in your life. Not at all. Sometimes that's where the most important data comes out of, right? If you get an unexpected results, that leads to new formulation of theory. Remember, the research process doesn't just end once you get your data. It feeds back into the theory, right? So let's not forget that part of it. Oh, I just said that. Here it is. So once you have your data and you've analyzed it, you go back to seeing how it fits within the hypothesis you'd created, and then that informs your theory again and will inform your next research question. So that's huge. Okay, that was a lot. That was a straight hour of me chatting directly at you. Please remember, this is just a quick review, key terms, all of that. Let me stop sharing my screen. Oops, I didn't do that. I'm going to stop sharing my screen and I'm going to share instead our, oh, maybe I can't. Hold on one second. Let me figure out how I can show you where we are on Course Connect, which is right here. Because I want to make sure we're all on the same page as to what needs to be done for today or for the rest of the week. Okay, so here we are. There's a lot of things hidden to you. This is the professor view. I wonder if I turn editing off. That makes things a little bit cleaner, a little bit. So you can see this is lecture 1. That's what we just did today. And then you're going to go on to stats discussion. And you will see here, that's part of the example we covered earlier today, talking about an example of a research question you would be interested in. What hypothesis would you have that would feed into that research question, and what variables you would want to measure? So I'm going to need all of you to create your own post from this and then to respond to at least 2 colleagues during the week. So all of this will be due by next week before we have class, and that'll go towards your participation score. So hopefully that's clear for everyone to complete. I hope you all have a wonderful evening. Please reach out if you have any questions. You can always email me or text me. You have my number, and we'll go from there and talk to you next week.